Okay, let's unpack this. Imagine a massive, multi-billion-dollar opportunity for American manufacturing, a real chance to bring production back home, create jobs. But here's the critical catch, and it's a big one. There's a severe and actually widening gap in skilled workers. It really threatens to derail this whole resurgence. Today, we're diving deep into how some cutting-edge tech, specifically something called spatial AI, isn't just, stepping up. It's actually transforming how we train people for the really advanced factories of tomorrow.
Precisely. And it's a fascinating convergence we're looking at here. You've got federal investment flowing in.
Right.
Advanced automation is becoming, well, the norm. And a fundamentally new approach to training is emerging to tackle this workforce challenge head on.
Okay.
So our mission in this deep dive really is to give you a shortcut to understanding this critical shift. We want to reveal the maybe surprising facts and the pretty profound implications of what people call Industry 4.0 workforce development.
Get everyone up to speed on what feels like a make-or-break moment.
Exactly. For American industry, yes.
So if you've been following the economic news, you're definitely hearing a lot about reshoring. This huge national push, right? Bringing manufacturing back to the U.S. And there's a massive commitment from the government. We're talking initiatives like the Chichies and Science Act, the Infrastructure Investment and Jobs Act.
Big ones.
Yeah, and the manufacturing incentives in the Inflation Reduction Act. It all adds up to potentially a $100 billion manufacturing opportunity. I mean, that number is just staggering.
It really is.
But what's the big roadblock? What's keeping this from really, truly taking off, or at least hitting its full potential?
Well, the core issue, like you said, is this critical skills gap. Think of it maybe this way. These federal initiatives, they're like pouring fuel on the domestic manufacturing engine.
Okay.
But for that engine to actually run smoothly, you need the right mechanics. You need a workforce that can competently operate these really sophisticated automated systems and, crucially, collaborate effectively with AI-powered technologies.
It's not the old factory floor anymore.
Not at all. It's a seismic shift from the traditional factory work most people might picture. We're moving way beyond purely manual labor to a much more integrated, intelligent environment. Humans and machines working together.
And the numbers really paint a stark picture here. If you're, say, a manufacturer today grappling with this, you're definitely not alone. Our sources show that a, staggering 77% of manufacturers report they just cannot find qualified workers for these new AI-integrated production roles.
77%, that's huge.
It's huge. And to give you a sense of scale, we're talking about needing maybe 500,000 new jobs just in semiconductor manufacturing alone.
Wow.
A sector vital for the economy, national security, and all these jobs need advanced technical skills. And here's the kicker. 65% of manufacturers actually expect this skills gap to get worse over the next 5 years.
So it's not getting better on its own.
No, it's a widening chasm, not just a bump in the road.
And what's particularly concerning is that the traditional training methods, well, they just can't keep up. For basic competency in these complex new roles, training can take anywhere from, say, 6 to 18 months, that kind of timeline. It's just a non-starter when technology is changing so fast and the need is so urgent.
You can't wait a year and a half?
No. And furthermore, a really significant amount of production time, we're talking 20% to maybe even 50%, is lost just due to equipment downtime.
Okay.
And a lot of this downtime, maybe most of it, could be prevented with better, more efficient, more responsive training. It's just a massive economic drain.
So this transition to what everyone calls Industry 4.0 or smart manufacturing, it really demands a completely different kind of workforce, doesn't it? It's not just turning a wrench anymore.
Absolutely. The manufacturing floor of tomorrow, it isn't just about muscle and, manual dexterity. It's more like a highly technical dance between humans and intelligent machines.
A dance, I like that.
Yeah. You need workers who instinctively understand collaborative robotics, cobots, right? How to work alongside them safely, efficiently. They need to grasp predictive maintenance using data to anticipate and prevent equipment failures before they happen, not just reacting after the fact.
Proactive, not reactive.
Exactly. They need to be adept at AI-assisted quality control, understanding how computer vision works, how machine learning classifies defects, and ultimately, it's all about seamless human-machine collaboration across the entire operation.
Okay.
These are very hands-on, highly technical capabilities, and conventional classroom methods, or even, traditional on-the-job apprenticeships. They just aren't effective enough for developing these specific, complex skills at the scale and speed we need now. The old ways just aren't fit for this new reality.
So, all right, if traditional training isn't cutting it, and we have this urgent, critical need, What's actually emerging is maybe the most promising solution.
Mm.
Our sources point towards a groundbreaking answer: EON Reality's Spatial AI Training Platform. But when we hear terms like spatial AI,
Mm.
it sounds incredibly advanced, almost sci-fi maybe. Can you sort of demystify what that actually means in the context of, factory training?
That's a great question because the term itself does hint at its power. At its core, spatial AI training is an advanced integration of extended reality or XR technology, so think virtual and augmented reality.
Okay, VR headsets and things.
Right. But it's more than just putting on a headset and seeing a simulation. Think of it as um, where the AI actually understands the 3D environment, the space, and crucially, how a human is interacting within that space.
Ah, so it knows where I am, what I'm doing.
Exactly. And this allows the system not just to present scenarios, but to intelligently adapt, provide real-time feedback, and even anticipate what a learner might do next. It makes the training incredibly intuitive and personalized, almost like having a digital mentor guiding you through a real factory, reacting to your movements, your decisions in real time.
A digital mentor.
Yeah, it's fundamentally different from just watching a static video or even using a basic simulator.
That deeper interaction, the AI understanding your presence in the space. That really sounds like the game changer here. Let's dive into some of the core capabilities, because this is where it gets really interesting for someone learning a new, complex skill on the factory floor. One key feature is training with digital twin manufacturing systems. What does that mean in practice?
Okay, so it means workers can practice on exact virtual replicas of entire production lines or individual robotic cells or even sophisticated quality control systems.
Like a video game version of the factory.
Sort of, but crucially, these aren't just static models or simple 3D renderings. These digital twins are dynamically fed real-time data from the actual factory floor.
Oh, okay. Live data.
Yes, this constant feedback loop means your virtual training environment actually evolves along with the physical factory. This allows for incredibly accurate scenario simulations, a level of fidelity that, traditional simulations just can't touch. You're practicing with real operational data, but within a completely safe and controlled virtual space.
So mistakes are learning opportunities,
Not costly errors or dangerous incidents.
Exactly. Okay, so it's not just about static machines then. It really covers these new types of collaboration we're seeing in Industry 4.0. How does it handle, say, robots working directly with people, cobots?
Absolutely. The platform offers dedicated collaborative robot or cobot training. In these immersive environments, you learn how to interact safely, effectively with these robots. You practice task coordination, understand and manage safety zones in shared spaces, optimize those human-robot workflows.
Building trust with the machine, almost.
In a way, yes. It's about building trust and efficiency in those shared environments, which is absolutely paramount when a robot might be working just inches away from a human.
Right.
And beyond that, there's AI-assisted quality control systems training. This is vital for understanding how to operate and optimize computer vision inspection systems, how machine learning algorithms classify defects in real time. And for the critical maintenance teams, there's predictive maintenance simulation. This teaches how to interpret that critical IoT sensor data, the signals coming directly from the machines, and how to implement proactive maintenance strategies using those dynamic digital twin equipment models we talked about.
So the platform covers everything from individual machines to QC to predictive maintenance. It seems like all these pieces are really building towards one big goal: that truly seamless human-AI collaboration. Is that where advanced automation integration comes in? Preparing workers for that totally integrated environment?
You've hit on a core insight there. It's absolutely about ensuring the human workforce isn't just reacting to automation, but is an integral, intelligent component of the automated factory.
Right.
Advanced automation integration training focuses specifically on the human element in a hyper-automated setting. Understanding how to supervise complex automated sequences, how to troubleshoot AI-driven processes, making those critical decisions that actually complement the machine intelligence. It's really about training for a world that's frankly already here, where humans and AI work together seamlessly.
All this sounds incredibly impressive in theory. But what does it actually translate to for a manufacturing operation on the ground? How can you quantify these benefits? We're talking about real businesses, right? They need to see a clear return on investment.
This is where the data gets very compelling, because the platform delivers measurable operational improvements across several critical areas. We're talking safety, efficiency, and equipment changeover, better automation integration, fostering that continuous improvement culture.
Okay.
We have a pretty clear before and after picture, which really highlights the transformation. For instance, take the average time to achieve basic competency in these complex manufacturing roles. Traditionally, that takes around 12 months.
A full year.
Yeah.
Yeah.
With spatial AI training, that's reduced to just 4 months.
Wow.
That's a 67% reduction. Imagine getting your workforce fully productive 3 times faster.
That's a huge boost right there.
Yeah.
And what about the cost? Onboarding new employees can be a significant drain, right?
Absolutely. The onboarding costs per employee, when you factor in the training time, the lost productivity during ramp-up, potential errors traditionally ranges from maybe $55,000 up to $170,000
Per person.
per person. With this approach, it drops significantly to just $24,000.
Okay.
That's roughly a 65% reduction, mainly due to that accelerated skill development. Think of the savings if you're hiring dozens or hundreds of new technicians.
Huge savings.
And then there's equipment downtime, always a critical metric for any manufacturer. Spatial AI training can help reduce that downtime from an average of maybe 30% down to 20%.
That 10 percentage point drop, what does that mean in dollars?
Well, it represents a 30–40% reduction in the downtime itself. And for a typical 200-person operation, our sources suggest that can mean an $8.76 million annual saving.
$8 million.
Annually. Just from reducing downtime through better training. It's not marginal. That's genuinely transformative for a company's bottom line.
When you talk about reducing downtime from 30% to 20%, that's not just a number that's potentially saving a factory from massive production losses. Can you maybe give us a quick, vivid example? How might a spatial AI-trained tech prevent a common, costly breakdown that a traditionally trained worker might miss?
Sure, certainly. Imagine a complex robotic arm on a production line. It starts showing really subtle vibrations, maybe barely noticeable to the human eye, but it's picked up by an IoT sensor.
Okay.
A traditionally trained technician might, wait for a more obvious failure, maybe a warning light to come on.
It's a standard procedure.
Right. But a technician trained with spatial AI, having practiced these predictive maintenance simulations, would immediately recognize that specific vibration pattern. They'd know how to access the digital twin model, so that exact robot, cross-reference it with historical data, and proactively schedule maintenance or order a specific part before a catastrophic failure happens and brings the entire line to a halt.
Ah, they see it coming.
Exactly. They've learned to interpret those early warning signs in a highly intuitive spatial way thanks to the training.
That's a fantastic example. Really brings the numbers to life. And beyond preventing breakdowns, how does this impact the actual quality of the products being made?
Right. So first-time quality rates, basically. How often a product is perfect right off the line improves significantly. They go from an average range of maybe 85–98% up to 95–99%.
Getting closer to perfect.
Much closer. And for that same 200-person operation we mentioned, this can lead to up to $4 million annually in quality cost reductions. Fewer defects, less scrap, less rework. Better trained workers simply make fewer mistakes.
Makes sense.
And it also translates to better safety. Our sources indicate around a 35% reduction in incident rates. That's thanks to immersive safety training for handling automated systems, chemicals, things like that.
Safer and more efficient.
And faster equipment changeover and setup times. Reductions of 50–70% are possible because workers can practice these complex equipment transitions virtually over and over until they achieve mastery without tying up the actual production line.
Those numbers truly put this into perspective. It's not just impressive, it feels like a genuine game changer.
What's the biggest shift in mindset this kind of rapid payback triggers for, say, a CFO or a plant manager who's typically cautious about new training investments? Is it less about the cost and more about seizing a competitive edge almost immediately? That's an excellent point. For a CFO, seeing an astonishing first-year ROI, we're talking 1,456% to 2,080%.
That high.
Yes, and a payback period of just 2 to 4 months, that completely flips the script. Training is usually seen as a cost center, right? Unnecessary evil with long-term, often hard to quantify benefits.
Right, you hope it pays off eventually.
Exactly. With spatial AI, it becomes an immediate profit driver. The conversation shifts from how much will this cost us to how much are we losing every day by not implementing this? It's not just about competitive edge anymore. It's about operational survival and enabling aggressive growth, especially when you consider the comprehensive financial impact for that typical 200-person operation. It shows over $14.56 million in total annual benefits,
Wow.
with an initial implementation investment of maybe $700,000 to $1 million. The economics are just undeniable, and that kind of data speaks volumes in the boardroom.
Okay, so this isn't just about individual factories seeing better numbers then. It really sounds like a much bigger play for the broader economy, for national strategy. Who are the key players involved, and what are the strategic opportunities for this kind of advanced training? It feels like it could really reshape entire sectors and how we think about workforce development.
Exactly. And what's particularly fascinating here is the timing. The platform launches right at this perfect convergence point. Federal manufacturing initiatives are ramping up, Industry 4.0 adoption is accelerating across the board, and workforce development priorities are, well, more urgent than ever.
Right place, right time.
Precisely. This creates unprecedented opportunities to build a really robust ecosystem. For example, EON Reality is already forging partnerships with major OEM equipment suppliers, think Siemens, ABB, Fanuc,
The big names in automation.
the biggest. And this is incredibly smart because it means they can bundle their comprehensive training solutions directly with the machinery. They can offer enhanced value to customers right from the start. So when you buy a new robot or a new system, the optimized training comes with it.
So it's integrated right into the supply chain, makes it a natural fit for manufacturers getting new tech. But what about reaching all the existing factories, the ones that might not be buying brand new equipment lines right now? How do collaborations with, say, industry associations open those doors?
That's where the strategic partnerships with major trade associations become absolutely crucial. They're collaborating with organizations like the National Association of Manufacturers, NAM, which has something like 14,000 members.
Huge network.
Massive. And the Society of Manufacturing Engineers, SME, reaching about 65,000 professionals. These partnerships provide essential industry credibility and, importantly, direct access to these vast member networks. It allows them to reach thousands of businesses who are, frankly, desperate for solutions to their skills gap problems.
Makes sense.
And additionally, there's strong alignment with state economic development programs. Think leading manufacturing states like Texas, North Carolina, Ohio, Michigan. This leverages existing state-level workforce development funding while simultaneously supporting regional competitiveness and job creation goals.
Okay, so private sector, state level. What about federal funding streams? We mentioned the CHPS Act earlier, but are there other significant avenues?
Oh, absolutely. They're actively tapping into significant federal manufacturing initiatives. You've got the Department of Defense, which allocates around $750 million annually just for manufacturing readiness.
Got it.
There's the Department of Commerce's Manufacturing Extension Partnership, or MEP, with about $200 million annually focused on helping small and medium-sized manufacturers. And critically, there's the Department of Labor's Workforce Development Funding. That's a massive $3.2 billion annually through WIOA, the Workforce Innovation and Opportunity Act.
$3 billion.
Yeah. These aren't just small grants. These are substantial ongoing streams of funding specifically designed to support workforce transformation and ensure American competitiveness.
So, with all these strategic avenues, OEMs, associations, states, federal funds who are the immediate beneficiaries,
Yeah.
which target markets really need this technology now and can see that immediate impact we talked about?
Well, the primary market segments are pretty clear. Definitely semiconductor manufacturers who are rapidly expanding under the CHIPS Act and need to train a massive new workforce, often from scratch. Automotive manufacturers are another huge segment. They're transitioning to electric vehicle production, which means reskilling almost their entire workforce for completely new assembly lines and battery technologies.
Total shift for them.
Total shift. Defense contractors also need these advanced manufacturing capabilities for critical systems, demanding the kind of precision and compliance that spatial AI training can deliver effectively. And, of course, you have medical device and aerospace manufacturers. They consistently demand extreme precision and operate under strict regulatory compliance, making this kind of verifiable, consistent training invaluable.
All right.
And for all of them, there are immediate implementation opportunities for training in those key pain points. Complex equipment changeover, collaborative robotics, precision quality control, and predictive maintenance. These are all areas where spatial AI can deliver value today.
What a deep dive. We've really seen how spatial AI training isn't just some nice-to-have or, distant future tech. It's clearly a vital, immediate tool. It's directly addressing America's manufacturing workforce crisis. It's enabling massive growth potential, and it's delivering truly incredible ROI. It really feels transformative, both for businesses and for the national economy.
It really does. And this raises, I think, an important question for you, our listener, to ponder. As technologies like spatial AI continue to bridge this gap between human skills and advanced automation, how might this fundamentally redefine what it even means to be an expert in a role?
Good question.
It's maybe no longer just about years of hands-on experience in the traditional sense, but perhaps more about the ability to dynamically collaborate with these intelligent systems. How will this shift impact not just manufacturing, but really virtually any industry that's grappling with rapid technological change? And what does it mean for how we all approach lifelong learning?
Definitely something to think about as you navigate your own learning journey in this rapidly evolving world. Thanks so much for joining us for this deep dive.